Token, small pieces. Bigger than a letter, smaller than a word. Lego blocks for language. And here's the wild part. This idea wasn't invented by some AI genius in a lab. It was invented in 1994 by a guy named Philip Gage who wasn't thinking about chatbots at all. He published a short paper called A New Algorithm for Data Compression in a magazine called the C-Brig Users Journal. He was just trying to shrink computer files to save disk space. That's it. That's the whole origin story. A disk space hack from 3 decades ago is quietly running inside every conversation you have with AI today. But you don't need to know how his trick works. You need to know what it does to your chatbot, because it explains some genuinely bizarre behavior you've probably already seen and just never understood. Why your chatbot can't count letters? You've probably tried this or seen someone try it. Ask a chatbot how many R's are in strawberry. It gets it wrong constantly. People clown on it endlessly online. Researchers actually tested this at scale. One study ran nearly 8,000 different words through GPT-4, asking it to count specific letters, and it kept failing in the exact same predictable way. Here's why. The model never actually sees STRWBERRY as individual letters. It sees the word in a couple of pre-chopped chunks, glued together like train cars. It's reading the shape of the word, not spelling it out. It's like asking you how many individual screws are inside your office chair. You don't know, you never counted, you just see chair. The model just sees strawberry as a couple of familiar pieces, not 14 letters. Why some people pay more for the exact same chatbot? Here's one that genuinely surprises people. If you type a sentence in English and someone else types the exact same sentence in, say, Hindi, Japanese, or Arabic, they get charged more. Their message costs more tokens. Every time. Why? Because these Lego blocks were built mostly by digesting English text from the internet. English got these short, efficient pieces. Other languages, and especially ones using different scripts, often get chopped into way smaller fragments just to say the same sentence. It's basically a hidden language tax nobody talks about, and it's baked into the tokenizer, not the AI's intelligence. A 2023 Oxford study measured this across 17 different tokenizers and found some languages need up to 15 times more tokens than English to say the exact same thing. A separate study on commercial API has found the same pattern. Non-English users systematically pay more, wait longer, and get less usable context window, purely because of how their language happens to get chopped up. Why numbers make AI act a little unhinged. Ever ask a chatbot to do simple math with big numbers and watch it confidently give you the wrong answer? This is a big reason. Numbers get chopped into chunks too. Sometimes 380 is one piece. Sometimes it's 3 and 80 split apart, depending on how that number happened to show up in its training data. Imagine trying to do long addition where the digits keep randomly regrouping themselves mid-calculation. That's basically what's happening under the hood. Researchers studying this found that simply flipping the direction numbers get chunked in right to left instead of left to right. Noticeably improved a model's math accuracy. It's not that the model can't do math. It's that it's not even looking at digits the way you are. Remember in part 1, words like delulu, rizz, sigma, words that didn't exist when the model was trained. Here's the fun payoff. The model doesn't need to have seen the whole word before. It just needs to have seen the pieces. Delulu gets built out of smaller fragments it already knows, kind of like how you can sound out a name you've never seen before as long as you know enough syllables. That's why a chatbot can handle a word invented last week without ever being taught that word directly. It's not memorizing vocabulary, it's remixing familiar pieces. So now, you know the secret. Your chatbot never reads your sentence. It shreds it into these strange little chunks first, and that single decision explains why it fumbles spelling, why some languages cost more, why math trips it up, and why slang doesn't break it. But here's the question that should really bother you. A token is just a number, a label. As far as the raw math is concerned, the token for king is no closer to queen than it is to banana. So how does a machine that only understands numbers know that king and queen are practically neighbors, while banana is standing all the way across the room? That's not tokenization anymore. That's a completely different piece of magic, and that's part 3.